and introducing our moderator, Safe.
Good morning, everyone. I'm going to ask our panelists to come on up to the stage right now, and I'm excited about the discussion that we're about to have. And I'm a big believer in allowing panelists to do their own self-introduction because it's the best way for us to learn about them that goes beyond their LinkedIn profile. So I'm going to go ahead and ask Andrew to kick us off on the far end of the stage. Giving us a little bit of insight quickly about his own background, and then we'll move to Ernesto and then Gaston. Andrew.
Fantastic. All right, thanks. Yeah, good morning, everyone. Everyone, it's a great session for kind of an AI-related topic. Everyone's got their own system in front of them here. It's like, don't nobody scroll on your email or any other fun games on these computers in front of you here. But I'm happy to be here. This is, I think, an interesting conversation that we can have around how to use some of the new technology to address just demand in a lot of ways that really comes from events, kind of peak needs. So I'm Andrew Hastings. I'm the executive director of the Open Mobility Foundation. We're a global public-private partnership that exists to support cities' use of technology to manage shared mobility, to manage the digitization of infrastructure, both together with the public sector and the private sector. We do that through the co-creation of open source data standards. I'll talk a little bit more about this throughout the panel here, but the mobility data specification and the curb data specification are two common digital languages that cities around the world are using to share the exchange of data and information between shared mobility providers, as well as in efforts to digitize infrastructure such as curb rules and regulations. I've been doing this for about 3 years now. I've got a background working for cities, spent about a decade with the city of Seattle, where I currently reside, working for the DOT, leading the transit program and program service investments, our parking and curb space management, started the new mobility program for the city of Seattle. So I bring a background from the public sector to this conversation.
Thanks, Andrew. Dr. Lee.
Good morning, everyone. My name is Dr. Ernesto Lee. I'm an AI faculty member right here, and this is actually my home, so it's kind of weird seeing so many people walking around in my house with all the suits on. But we like to think of ourselves at Miami-Dade College as effectively the employment engine for the county, really. And so we have an applied artificial intelligence program. We work often with the county. We work with the Department of Transportation, and we look for applied solutions is what we do. That's our contribution in the AI space. So with that, I'll turn it back over to you, Safe.
Thanks, Dr. Lee. And Gaston.
Thank you. Good morning, everybody. My name is Gaston Kelly. I lead operations and customer success for Uber Transit. Many people may not know that Uber has a team of about 25, 30 people whose entire goal is to help transit agencies deliver better service across a variety of different use cases. Everything from first last mile to microtransit to on-demand paratransit. I have a team of planners, of former folks from transit agencies, of business people, everybody, and all we do is think about how we better support transit agencies. That's what I do now. What I did before, about 10 years ago, I joined Uber, and I brought Uber to Miami and Broward County and Palm Beach. So I'll answer some of the questions in the conversation from my transit hat and mobility. I also have experience in car sharing and bike sharing, student pilot, policy, and a bunch of other massive experience. But then I'll also talk about the early days of Uber and how we thought about AI and how we can really talk about managing the surge in demand and how to make a more efficient delivery of service so that folks can get a reliable trip whenever they need it, while also having the drivers just create a healthy ecosystem of earnings and wait times.
Thank you so much, Gaston. And for those of you who might not know, my name is Saif. I'm proudly serving as your moderator. I'm the founder of Lab 22C. We're based here in Florida, and we serve as operating advisors and investors to the world's best technology companies, institutions, and leaders. And we're all here because we care a lot about understanding how is AI being utilized around real-time solutions for demand overflow. And now more than ever, especially at a conference like CoMotion, we know that AI is infused into every discussion that we're having in every sphere of human endeavor. And for what we're doing at CoMotion today, I wanted to kick it off with an open-ended question for all of our panelists. And particularly when we think about that unpredictability around managing surges, whether in our South Florida, it's Art Basel, the Super Bowl, or the World Cup, which is coming to South Florida next year, or sudden weather disruptions. What is the most surprising or insightful thing that each one of you have seen respectively in your work around how AI has helped us understand about that rider behavior, shifts in user flows, and how that ultimately impacts transit? And so with that, I'm actually going to go ahead and start off with Gaston and then sort of populate onwards. What are the sort of unknown genies that have come out that AI has actually given you unique and hidden insights about the disruptive changes for rider behavior and transit flow?
Yeah, it's a great and timely question. I'll give you a little bit of an example of what we learned given our deployment, our support of the World Cup in Qatar a few years ago, which Argentina won, which is where I'm from. So I just wanted to make sure we talked about that for a moment. So something we do a whole lot is we have a team that works with the venues in trying to create a better, a smoother flow of the folks who are coming out of the stadiums. Because I think you use the term unpredictable for some of these surges. I would challenge and say we can kind of predict them. I think anybody here in the room can tell that when a game finishes, we're all going to move out. But I want to focus on getting to the stadium. And I think what we've learned is these right now, I'm going to run through this field because I see the stadium and I don't want to wait. So I think what we're seeing is the data, it can tell us so many things. Ultimately, there's a human component, psychology, there's a behavioral component that is really, really important to tackle as well.
I appreciate you bringing that human element to the table. Andrew, Open Mobility Foundation, how do you all think about this unique problem set?
So I think what's interesting right now in this space is that the notion of dynamic response. And there's an element of pre-planning, but how do you respond as agencies, as operators, as riders to unplanned or kind of anticipated situations? And the mobility data specification kind of became used by cities globally to manage micromobility. Think of originally really scooters and bikes. For the most case, didn't need to be in real time. This was about cities understanding the usage of these devices on their streets. How many of them are out there? How many are active? Where are they at any given time? And then also be able to communicate policy out to those devices and the operators in the form of speed limits or geofence no-ride zones, things of that nature. Generally, a situation that didn't necessarily need to be dynamic or real time. Now MDS applies to passenger services, to things like car share, taxis, Uber, autonomous vehicles, services that their nature have a potentially more real-time need for, let me put it this way, a need for real-time information. And I'll use this project that we're working on in the city of Seattle, actually, as an example of how this nature of dynamic response has changed. So the city of Seattle had autonomous vehicles testing on their streets, and they secured some funding because they wanted to be able to communicate out to AVs, connected fleets, systems like Google Maps, emergency response zones in real time to give those services an opportunity to avoid those potential congestion spots. We've all had the experience where you come up and there's a road closed or a road impacted because there's a fire or medical response. And again, those things happen dynamically. No one can really plan where the next fire or medical emergency will be. And so using that same idea of being able to communicate policy digitally out to these operators through the mobility data specification, the city is translating 911 dispatch calls into that digital language via an API, making it available for connected fleets when there is an emergency response conflict in the roadway. This is an example of how cities are now able to make this information available in real time for operators to use to respond to and hopefully avoid some of the congestion that inevitably comes with the impacts of unplanned emergencies. Starting with emergency response, but you can imagine, related back to major events, where in planning for major events or unexpected crashes or other incidents in the right-of-way, this type of kind of real-time information could be valuable. So we're trying this out for the first time, moving toward this more dynamic kind of nature of information.
What I find fascinating about this, and I have to drop a little bit of dad wisdom here. So a couple of years ago, there was a Taylor Swift concert here in Miami at Hard Rock Stadium. And my wife took our daughter along with a couple of my daughter's friends. And actually, at the very end of the concert, there was a massive, for those of you who are native to Miami, sometimes in the middle of the summer, we do have like these hour-long tsunamis where it rains sideways. And as they were leaving the concert, along with 60,000 other Taylor Swift fans, this tsunami just appeared out of nowhere. So based upon this framework that you're describing, that type of anomaly would have made its way into the system. So when we think about smarter cities and we think about transportation planning, by the way, that weather system that just kind of kept away all the rideshare operators, and in the end, the way my wife and daughter and these young women made it home was yellow cab taxi, and then my wife wound up taking, like multiple stops along the way. But I love the framework that you're describing, Andrew. That information through APIs would have made it somehow into the ride-sharing protocol so that drivers and others that are thinking about how to make those adjustments would have. Dr. Lee, how do you think about some of these surprising, and you've got a great background, being a professor of practice, coming from the private sector, being in AI and blockchain, and now being able to bring that to our students at Miami-Dade College. How do you think about these surprising anomalies and how they show up?
First of all, I was in that traffic too. So I have a 14-year-old daughter.
Yeah.
I was at the Taylor. I was a Swiftie. I was out there.
There's shame in the game.
All of that. Yes. I was there for my 14-year-old daughter, though. I want to make sure that part is very clear. But the first thing is that we noticed, looking at a lot of transportation data just locally, right, just in the county, we noticed that there were two types of, quote, events, if you will. There were unpredictable events, emergencies, right? We can't predict them by their very nature. And then there's events that were predictably unpredictable. And then for us, it came down to the quality of the data. With the right data, then what appears to be on the outset to be a random event is actually something that is predictably predictable. That was number one, a huge insight for us. And so the second part was, how can we uncover these, quote, micro patterns is what we looked at. So initially, if we just looked at transit data, we only looked at transit data, then it gave us a very narrow view on what we could predict. But once we started to include other types of data, like for instance, we started looking at hotel bookings. We started looking at social media data. We started looking at rental car data and these were all like effectively tremors before an eruption. We could start to tell that, hey, there's going to be an event, and it was universal across a lot of use cases. You mentioned Art Basel, you mentioned the Super Bowl. When we were able to go back in hindsight, we were able to find all of those micro patterns. There was a speaker up here before, Maurice, I don't see him here, but excellent at uncovering those micro patterns that help us predict when there's going to be an event. And one of the patterns that he actually showed us was the cleanliness of the bathrooms right there in the Miami airport, and how there is a direct correlation between how clean the bathrooms are with the amount of food that people are going to eat. That makes perfect sense, because if your bathroom's dirty, there's no way I'm going there to buy food from you. And so we took that principle and tried to apply it to transit. And so instead of just looking at the transit data, we started looking exclusively at the at some of the other data types. Weather was another big one as well. So your data framework would have been perfect for that event there.
What I love about that is that we know now more than ever that we're floating in an ocean of data. And there's a great quote that says that we're not suffering from information overload, we're suffering from filter failure. And I think that it's more relevant than ever. I wish I could claim that I would totally tweet that out. And my friend Pedro back there would be like, that sounds like something Saif would say. I didn't. It was somebody much smarter. Gaston, I'm going to jump to you because obviously being the Uber guy, all of us have infinite amounts of curiosity about sort of the magic that exists on the other side of the app. And Uber obviously has seen and had to manage its share of real-time spikes in demand. You talked about what happened at the World Cup in Qatar and even something as simple as a field versus the entrance to the stadium. How are these AI-driven tools like dynamic pricing or smart dispatch being adapted or applied specifically for public transit and microtransit partnerships? Because I know we all know about it when we think about rideshare, but it really shows up for a lot of people, especially when we think about workforce, around how this can be integrated into our public transit and micromobility options. And I know many of our friends who are in the audience represent these novel solutions that are helping us reimagine what public spaces can look and feel like.
Yeah, absolutely. I'll talk first about kind of the evolution of surge pricing, and then I'll talk a little bit about how we apply some of those learnings and how they manifest themselves in our Uber Transit partnerships, of which kind of Miami is kind of the center of our partnerships and innovation in the work we do. So back in 2013, I joined Uber for the first time and launched Uber in Providence, Rhode Island. And the way surge used to work, the concept of dynamic pricing, I think, is pretty intuitive. There's more demand than supply, so you increase the prices to make it more attractive to the supply side of the equation so that more drivers come out. It feels it's become magical, but in the olden days, it was me on my computer over a geofence of the entire city of Providence, Friday evenings when Brown was partying, saying 1.5x, 2x. So we were kind of trying to approximate the effect we wanted in like a really, really rudimentary approach. We got better quickly. We figured out, and in the context of Miami, it'd be like saying the entire Miami-Dade is going to surge Friday evenings. Well, that wasn't getting the effect that we wanted. So then we broke the city down into smaller neighborhoods. And we got better about that, but we still weren't great. Eventually, we got to a point where our algorithm and our AI is able to learn based on how people are opening the app, the events that are happening, some of the points that Ernesto and Andrew talked about, ingesting some of these things, still pretty rough, but coming up with a pricing mechanism that is down to the block level. And what was happening next? Well, it was surging at the block level, but the drivers were all going to the same place. And then we expanded it, because what happened on the rider side, everyone figured out when it was going to surge, and they started moving away from those big hotspots of demand. They're not in the same bar, they're walking 2-3 blocks. So now we're spreading out the demand, and what that does is it kind of brings down the overall surge, keeping prices down, making the system more efficient. So that's kind of where we are now. We're at a place where we're moving into kind of predictive pricing, trying to get the supply side to match up with the demand side, making it more efficient, bringing prices down, keeping it reliable, and wait times at a level that is agreeable. And obviously, people are still making their own independent choices. Some will wait 20, 30 minutes until the prices go down even more. They'll walk a mile. They'll take a bus farther away and then take their Uber or their Lyft. Now, when you get into how this works in the public transit sphere, with Miami, I believe it's the Metro Connect program, the microtransit program. If you think about microtransit, it's vans, and it's more dynamic. So you kind of have much more flexibility into how you service that demand. Now, when you have a demand spike for whatever reason, whether it be a tsunami or bars or a sporting event, you're capped at how you can service those trips. So what do? Well, we partner with the software companies and the microtransit providers so that when their system kind of hits capacity, they can send those trips to Uber. And we have in our back end the dynamic pricing that is going to make those trips reliable and still much more affordable, but the folks are able to get their trips. So now you get into a place where you bring smaller vehicles, dynamic pricing on our end, And we're just there to support the system and make it much more efficient and much more resilient to some of these demands.
I think that's thank you for sharing that, and that was fantastic insight, particularly around version 1.0 of surge pricing. That had to have been a lot of pressure and could have made you both popular and unpopular if any of your friends knew about that at that point in time. And I think it's a perfect segue actually to the world that you're a part of, Andrew, around open data platforms. Right, because we just talked about the use case, particularly around how this applies and plays out within public transit systems, and your foundation supports those standards for shared mobility. And I'm curious to hear and get your take on how are these open data platforms and interoperabilities enabling cities, and there's a lot of folks here that are involved in public planning exercises and are charged with that in our communities. How is this enabling cities to better prepare for demand overflow in real time, not just around epiphenomenal things like Super Bowl games, et cetera, but just sort of the day-to-day reality of life within urbanly congested cities around America? It's
a good question. I actually want to start in the context of the upcoming World Cup, partly because it's a forcing factor that is driving some change that we're seeing within cities. And there's nothing like a major event or a series of events like the World Cup to help motivate, especially on the public side, motivate to get solutions in place in advance. That can certainly provide solutions beyond just that special event. I mean, you see that around most, whether it's past Olympics or other types of things. There are policies and programs put in place that live long beyond the event itself. But talk about the World Cup for a second, because I'm a soccer fan. Go Seattle Sounders, especially being here in Miami. Have to put that MLS plug in. But so the World Cup is not necessarily a solely unique event, but is going to be really interesting here in the U.S. and North America in particular, because it's not just a single today and that sort of thing. So the OMF is a city-founded and city-led organization. My board is made up of city transportation executives. So we really go and respond to what cities see as emerging challenges. During COVID, in particular, there was this massive increase in demand for curb space, from deliveries, from needing to reappropriate that space for outdoor seating, across the board. You had both the logistics, but also food deliveries, et cetera. Cities didn't have good ways of managing that space dynamically. And so they got together and with the private sector, co-created the curb data specification. Now, they started with the curb, but think about CDS as this common digital language for digitizing any public space rules and regulations. But the idea is that in the lead up to the World Cup, cities have an opportunity to create a digital curb inventory and then manage that space more in real time, both from the perspective of actual pricing. So why should just Uber be able to surge price? Why shouldn't cities be able to surge price their curbs, for example? If there is demand for that space and private lots are charging $30, $40 and the on-street parking is still $3 an hour, like that, there's an imbalance there. We're not fully effectively utilizing that public good. So there's an opportunity, not necessarily endorsing the idea of surge pricing the curb, but you could manage it more in real time. But then also from the operator side, whether you're Uber, whether you're another type of on-demand service, microtransit, et cetera, having the predictability of where to go to drop off or pick up passengers during that event and around other types of major events is critical. I fundamentally believe Uber does not want to cause congestion. They don't want to be part of the kind of the mayhem that occurs. Actually, from my hotel room, looking out down on the after the basketball game last night, that chaos is everybody trying to leave the stadium at the same time. And so cities now have the opportunity to...
The chaos was the heat just didn't do it, unfortunately.
Oh, well,
sadly.
I don't know what
happened.
happened,
Pressure
but...
on Tyler Hero, we love him. This is not the year we're rebuilding. Anyway, continue.
There you go. Hey, you know what? Yeah, all right. No comments there. So being able to digitize that curb space and then be able to create not just fixed zones for Uber and taxis and autonomous vehicles, et cetera, but zones that can actually change based on demand. Because if demand spikes, cities should be able to dynamically apply more of that curb to accommodate the pickup and drop off, and not just wait to take a lesson learned from it and know, hey, we don't have enough pickup space here. If it's monitored and managed in real time, that curb allocation can also change in real time.
Gaston, it sounded like you wanted to jump in and say something or sort of add an additional thought to Andrew's comments.
Me?
Yeah, go for it, man.
And an endorsement for surging the curb space, number one. I mean, I think it's something we're considering at Uber, and I think we're seeing the positive impact right away. I'll give you an example. I just came from New Orleans, where my wife is from, and they have this big event called Jazz Fest. And in the fairgrounds, they have about 12 stages and incredible food, and it's a really good time. Picking up people, because it's in the neighborhoods, we certainly don't want to be part of the chaos. Why do we not want to be part of the chaos? Well, our system becomes much less efficient, meaning the drivers aren't making the earnings they're expecting to provide service during a high demand event. That means the capability of a driver to complete a trip goes down to like half a trip an hour, one trip an hour. Really, we'd want them to be somewhere in the realm of like 2 to 3. So what do? We take these events and we essentially block requests from like a 2-block radius from the fairgrounds. In this case, you could do it from the arena or from the Hard Rock Stadium, wherever. You open the app and you can't request. It takes your PIN to these locations, so we decide and we work with the city and we work with everybody who's involved, and then we take that demand into these corridors so the drivers can have a better time getting in and getting out. Now, we are asking the folks who are able to walk a couple of blocks, but what do they get in return? They're going to get a much more efficient system, which ultimately manifests into a more reliable experience. The wait times are going to be more predictable, and the price is going to go down. So I think folks at MIT did a study, and these kinds of mechanisms with the geofences and the dynamic pricing, you're bringing system efficiency up by like 12, 30%. So what you're saying is exactly right. You just kind of have to, we don't want to be part of the chaos. We don't want to cause the chaos. We don't want to be part of the chaos. No one wants to be part of it, riders or drivers either. And these mechanisms and using pricing and using geofencing and using urban planning and local knowledge, which by the way is critically important, because if you don't know the city, this isn't a Google Maps spreadsheet exercise. You kind of have to be there and feel the pulse. And once you get that right, then you're off to the races.
What I love about what you just said, Gaston, and for some of our folks who are public sector, and I know I came from the public sector, those unique insights from people who work in public systems and transit systems that sometimes just don't present themselves unless you have that ground truth are so critical in helping to inform the systems that we're creating. And Dr. Lee, I'd like to jump to you because I think that this is something that is relevant for all of us when we think about building 21st century cities that are livable, that are walkable, but that also are democratizing to every quadrant of the community. How do we think about utilizing training AI to be better at forecasting transit surges, but also thinking about things like algorithmic bias and how we ensure that we don't leave behind historically underserved communities? Recently, I was at a health clinic in the Opelika neighborhood here in South Florida, And I learned, for example, that in Opelika, I'm a Miami native, but it didn't occur to me that that free clinic I was at was the only public health facility in that neighborhood. And so we know that algorithmic bias oftentimes sort of works its way in. And as somebody who's an educator now and comes from practice, how do you think about that, and how does that inform some of the work that you get to do here at Miami-Dade College in equipping the next generation of data scientists and people who are building these systems for us?
That's a great question. Hopefully that question gets asked more and more often. Last night, I looked at a student presentation, did something very simple. He looked at services available by zip code with respect to SNAP benefits. And he was trying to see if there's a correlation between parks and public service type of amenities as they correlate to income levels of the residents. And I don't think I need to tell anybody that, across the board, there's almost a direct correlation between income and services available. He expanded that and went one level further. He started looking at where the exits off of 95 and the Turnpike are, and he saw that there were exits were skipped in certain neighborhoods. So he went there, and he was able to have a direct correlation between income and where exits don't exist along the highway. And he did one last thing. If you go through a lot of the side streets in certain neighborhoods, you'll see the bars that prevent you from kind of going through the streets. There's no logical reason why they should be there. The streets were built for a reason, but in almost every case, you notice that there was a correlation between income and kind of where those types of things that we talked about exist. So AI can't fix inequity. I mean, you're never going to find what you're not looking for. So I'll kind of start with that. So forecasting, as we kind of talk about forecasting, traffic demand surges, et cetera, it's not just about where the crowds are going to be. It's kind of about also how people can get there, and it's difficult for them to get there if they don't have highway exits nearby, if the streets are blocked to even get there, if there's limited bus routes. So what we kind of notice, this is just from the data that we looked at, is that predictions without access is kind of, a little bit, it's privilege in disguise is really what it is. So we don't want to turn our residents into spectators, especially when we kind of look at large events or any events really. So what we had proposed was making sure that we include the infrastructure, because that's part of our job, is to make models that can make predictions as to where there's going to be, quote, events. But we noticed that we need to include the infrastructure as part of the data that we use to build these models, so that we can start to identify, number one, and overcome some of those things. The other thing that we noticed also from a data perspective is when we looked at weather data, we noticed that with the weather data, it was actually very ironic that when you look at weather data, it doesn't just change the traffic patterns, it changes human behavior. And so it's not just that the traffic is going to be different, it's that humans make fundamentally different decisions. So they leave early. And if we don't look for that, we don't see that. They leave later sometimes. They change their destinations altogether. So when we're trying to make predictions about where events are going to be, oftentimes we see congestions in places that are completely unrelated because the humans have made kind of just fundamentally different decisions based off of the weather. So here's one other thing too that we noticed. We noticed that when we trained these models with the data that we were provided, they were great at predicting where there's going to be a need for a surge. We were great with that. I think that problem has been solved. But what we were not great at is understanding the conditions that created some artificial blockers. That's the part that's missing from a lot of these algorithms, right? Why? Some of the things that we mentioned in the beginning. Why do we have some of these blockers? A lot of the models don't address that. So that's something that we're kind of looking at. And the last thing I guess I'll mention about that is that we look at this, a lot of this, it occurs as almost invisible. And invisibility is a data problem. It's absolutely a data problem. So we look at all of the IoT, we look at all the sensors that we've placed around all of these cities, and it begs a very important question: where are we putting those sensors? Because the better the data, and the better the predictions that we're going to have. By the way, I'm a vegetarian as of like 1 week ago, and I am so cranky. You have no idea. I am unbelievable right now. Decided I was going to make myself a salad last night with some vegetables that I had bought about a week and a half ago. My wife was telling me, "Don't do it. It's a terrible idea." But no, I did it anyway. Horrible, right? Worst salad ever. But the point is AI and data is the same way, right? If we give it bad data, then we're going to get bad results. If you give it bad ingredients, doesn't matter how good the chef is, it's going to be terrible, right? Just like the salad was absolutely terrible. And I say that because invisibility in certain parts of our community, it's a data problem. So as we place these IoT devices around the city, where do they go? And if you skip over neighborhoods, or if they don't have as much data, then you're going to have an algorithmic bias problem, because we won't have as much data in certain parts of our community as others.
Thank you for sharing that. As you were talking, I'm reminded of a famous quote from the former mayor of New York, Mike Bloomberg, who said, "In God we trust, all others must bring data." And I think it's really relevant for what you're talking about. And also, kudos to you for your students for integrating, looking at things like SNAP usage data sets in helping to understand how it is that we create frameworks around interoperability in our city. So I'm going to ask one final question to Andrew, and then I want to open it up for some questions from our audience. And I think it's timely, because we're talking a lot about data, and you can't talk about data without talking about privacy. And how can public agencies balance this need for rapid tech adoption with the regulatory and data privacy concerns that often accompany
cities are undertaking to bring technology into their processes and operations far beyond just what the OMF is involved with. But so I feel like in answering this, I don't want to answer that question for sort of the writ large.
You don't speak for everybody.
Exactly, right? I mean, because there are some real, and especially there's data management practices are some of that is a real capacity constraint in cities. No, so again, I mean, cities in many ways don't lack information. They lack the insights from that information. But then also, in addition to that, it's how do they make sure that the management of that data is sound, and that the vendors they're working with are sound. So from at least the perspective of the Open Mobility Foundation, we don't actually directly handle any of the data. We're convening a forum where the standards or the definitions of that data are decided upon, and then the data actually flows between the operator or the software company and the city or public agency. But we've spent a lot of time, and especially back in the kind of the early days of micromobility, when MDS was kind of catching on. As micromobility spread to cities around North America and then Europe and eventually the world, there was a lot of concern about kind of tracking the use of scooters and bikes. And so one of the things that we wanted to make sure is that MDS as a common digital language was compliant with the strictest privacy policies and guidelines that are out there. And especially if MDS being used by cities in Europe, it needed to be GDPR compliant, which is Europe's very high bar for privacy that in effect has also applied in many cases here in the US, because we actually don't have a national sort of privacy kind of policy or framework. And so that essentially ensures that if agencies are in their efforts to understand and to plan their systems, if they're looking at how these bikes and scooters and potentially other shared mobility services are being used, that it's all about the device and nothing about the user. And so that's number one. And then number two, MDS is made up of a whole series of fields of data. And ultimately, up to the agency in their geography or their own individual policies, which of those fields of data to actually require, to use. Because some agencies want additional information than others, and so it's not a one-size-fits-all approach. Again, this does not address kind of the larger issues around AI and privacy, but in terms of cities, the perspective of just managing a transportation system, the more information you have about the way people are moving around that system, the better you can manage it. And so, using privacy as a reason not to understand how the system works, that's not good enough. So we need to dig in several levels deeper and say, okay, so what is the most concern around potentially elevating privacy risks in the kind of mobility and transportation space, and then make sure those are the components that are being left out of the conversation if they're the real concern.
Thank you for that. I want to open it up for some questions from the audience. We've got a great panel here and lots of issues. Sir, at the back, I don't know if we can get a microphone moving around. Thank you so much.
Thank you. I know we spoke about digitization, digital infrastructure, and everything else. So there's so much of data floating around. And I think one of the speakers, I think Andrew, mentioned about data management as well. I've been trying to come up to speed on how do we handle this data, how do we use it to gain insights. I came across a term called dimensionality reduction. Can anybody throw some light on that and how that can be used with that large sums of data?
Professor?
Okay, great. So I actually teach in this classroom, so this is very, I feel right at home. But dimensionality reduction. Bottom line, just think of a spreadsheet. A spreadsheet, right? Spreadsheet has a bunch of columns. How can you remove some of those columns and still keep the essence of the data in place? That's dimensionality reduction. All of this data that we have coming in from all of these IoT devices, it's almost overwhelming. How can we process that in, quote, real time, right? And so then there's, it's a huge demand. It's very important for us to only bring over the data that's valid, viable, and relevant. So dimensionality reduction is very important from that. So we're going to capture everything, right? I mean, we'll have temperature, just everything. What do we need to build our models? And then we start talking about scale and scope. You can imagine all of this is going to be processed. So there's going to be some GPUs, there's going to be some RAM, there's going to be some hard drive in place, and we only want to keep what we need so that we can get what we want out of the model. I'll give you just a quick example. I'm a researcher. I have published a paper, ironically, on how you can identify pulsars, right? So imagine you scan the sky, how can you identify pulsars? Pulsars make up a fraction of that data. Think about how that applies to the world of transit, right? Now we're trying to predict, instead of a pulsar, we're trying to predict where there's going to be a surge someplace. What data do we need exactly? One of the things that we noticed in a project that we worked on was that when you train these models, because we had to review a lot of the models were trained with data that was readily available. And so basically it treated evacuations from hurricanes. It treated them as an outlier. It treated events like this. It treated them as an outlier. And so effectively exactly what we were trying to predict was treated as noise instead of the exact signal that we were trying to predict. And the only way that we can kind of go around that so that we can have better predictions as to where there were going to be events was to go in and do dimensionality reduction so we can make sure we get the data that we need to optimize our model. I won't go into the technical parts of that, but you ask what is dimensionality reduction, there's your answer.
Dimensionality reduction. Okay, I now feel smarter. But I'd sum it up as it's not more data, it's better data. And that's something that we talk a lot about with the cities that we work with, is that you don't necessarily need to ask for everything, mostly because you're not going to use it all. So simplify and figure out what you're trying to accomplish and what you need to do that.
Other questions? We have a microphone coming your way.
I'm just thinking about the partnerships you're saying, I think, on surge pricing and getting people out of the core nodes where there's the congestion, right? One of the key players, I think that sometimes is overlooked, are law enforcement agencies. They'll shut down a road, right, for pedestrian flow across a major artery or whatnot. And so that obviously kind of leads to some of those challenges, right? You look at the Miami Heat Arena, and any given evening, there should be buses theoretically flowing up and down Biscayne Boulevard, and they're not because, again, they're trying to get people out of the arena, but that obviously has knockdown effects to transit and so forth. Just thinking about similar types of contexts there. So just would be great for us to kind of keep those agencies in conversations when we're coming up with these solutions, because they kind of have veto power over our roads, particularly during events.
Yeah, I think it's a wonderful call out, and we're maybe not predictive enough yet there. Those partnerships are evolving. The good thing is the driver side of the app is really quick to react. So drivers actually have the ability to signal, hey, this road is closed. And if we get a number of those within a short time span, then our internal routing is moving Uber drivers away from that area. So it's kind of like the crowdsourcing information when you don't have the established relationships with law enforcement or the ability to predict. You kind of do it a little bit more reactive, but still quick. But I think it's critically important. Otherwise, you're going to get a long line of rideshare drivers getting stuck, and the whole thing breaks apart.
I think we have time for one more question before lunch. I'm not a repeat question asker, so if there's anybody else, I'd love to get a question from you. And if we don't have another person, okay, we got one other person.
Hey, good day, everyone. Just sitting here and just a few thoughts going through my mind. I would ask just to pick you guys' brain, since you work on these things all over the world, you have a better insight. Where would you say you compare Miami to Singapore, Japan in terms of advancement where AI is concerned and innovative solutions to building? Like, I order food on Uber, it comes to my door, I don't want to go downstairs. I want to be able to go into the lobby, take a vacuum up to the 6th floor, and I can get it. Where are we with that? How are you guys trying to incorporate that with developers to change how we order food?
Well, I will say we're behind some of those incredibly innovative cities that are able to push the boundaries to really be futuristic. But I think those ideas are coming faster than we imagine. And I won't answer from the Uber context because I'm not super in touch with it. But I know some startups who found a way that if you follow, I believe it's the gas lines in the city, you can actually create all these vacuum tubes to do the first mile, last mile delivery. So that I don't know if the food will make it to your door, but the driver won't have to drive all the way in. They can kind of get into the cloud kitchen facility, put in a tube, get close to a distribution center, and somebody in a bicycle brings it to you, or somebody walking. So I think that's happening, but I think it kind of comes down to a variety of things. Usually it's the political will. It's the ability to manage all the local permitting and the policy and the legislation and do we need it and the public engagement. That can really slow things down. I think other cities globally are able to just move a lot faster there because that's kind of the norm and the expectation. I think we're close, but
Yeah, I was just gonna. It's a really good point and fascinating. Where perhaps from the U.S. perspective, we are behind, mostly because we have a particular way of doing things that it's like we're just fighting inertia. Where there's less, I don't know, more creativity or just freedom to try new things elsewhere. But I think we'll get there. The idea of the default option is having food delivered to you. That's, I think, still a relatively new concept especially for Americans. So we haven't, our real estate, our commercial development systems haven't caught up with that notion. So I would imagine they're going to in the not too distant future, because that appears to be here to stay. That notion of I want to use my phone to be able to have whatever it is, whether it's food or whether it's just toilet paper brought to me directly instead of having to go out. So I would imagine our built forms, built environment will adjust to that over the next few years as well.
Yeah. And one of Uber's co-founders, Travis Kalanick, when he went and started Cloud Kitchens, his thought was, why do we have kitchens in our houses or apartments? We should just disrupt the kitchen. Get rid of it, use it for something else. So we're going to get to a place where cooking the food somewhere else and delivering it in a way that's sustainable and it's efficient, we're going to be able to claim back that square footage in our living spaces and use it for anything else. Maybe a little bit farther away, but I think other places will get there first.
Well, thank you so much to our extraordinary panel. Please join me in giving them a warm round of applause for their insights. Thank you.